So this last little bit has just got some random equations. Now, there's four here. I'm going to go through them on why they are like that. But when it comes to SAC or an exam, we're not testing you on why the equations are the equations. You just need to identify when you need them. I'm not just going to give it to you because I feel that it's important to know where they come from. So it just sets in a little bit more. So for example, if I had a triangle and we've got an angle here, got an angle here. These ones have to do with 90 degrees. You can see this box here. Where's the 90 degrees in these? You can see them. Okay, are pi's and 2's. These are 90 degrees. So if I call this angle here and this one here, how can I rename this one? How can I label that? Okay.
90 minus theta.
A 90 minus theta. Okay, good. But let's write it in the case of pi on 2. You are correct there. We're good? Three triangles need to add up to 180. We've got a 90. Got an angle. And if this is the angle, what do we call this? What word would you use? Starts with C. Okay, like the yin and the yang. Complementary. Thank you, Perry. Complementary angle. If I now label A, B, and C, and I start getting my cosine, what over what, Maya, is my cosine from this side here? Which two letters are involved? A and C. Okay. Now, so we've gone from one corner. Now let's look carefully. Let's go from this corner here. What if I did the sine of pi on 2 take away the angle? That means we're coming from this corner, but the sine now. Nathan, what two letters make the sine from this corner? Not quite. It's the opposite of the adjacent from here.
Oh.
A over C. You can see how these two are the same. That means we got this equation here. Okay, which is this one. They're just backwards in a way. Let's do it again. Let's go from here. Let's do the sine now. Any sine of this angle here? What two letters?
Oh, B over C.
B on C. And what am I going to ask you to do next? Let's give it a go. Emily?
I'm going to do the same thing, but with the pi on 2 minus theta.
Pi on 2 minus theta. And which one am I going to reach for?
It'll be B on C.
B and C for which ratio?
For sin.
For sin? Or
Oh, for constant.
cosine, yeah, good. Okay, which gives us these two. Okay. Now that you know where it comes from, you can go just memorize that or memorize that if you're more of a visual person. Okay, let's go to the next one. So this one, we are all good that this is that. What I'm going to do now, I'm going to push this triangle. Doesn't look the same, but it is, okay? Just leave it. So this triangle here, we're just pushing it onto the y-axis. Are we okay? Okay. So therefore, this length here is our cosine theta. This is our sine theta. Are we good with that? That's our x, our length of x, and our length of y. Therefore, if I push this triangle, Tim, what's on top? Where is the corresponding line based on here? Is it the cosine or the sine?
Sine.
It's the sine, okay? I'm just going to color code it so people can see clearly. This is green, which is this bit here. And this is our red. Okay? We just pushed it. Okay? So, we have this angle of our that we're interested in. However, it's moved. By how much?
90.
90. And what do we call that 90? What's the other way of saying that?
Pi over 2.
Pi on 2. Okay? So what are we saying here? Let's look at this point here. Can someone tell me, this new point here, what's the x coordinate? How can we rewrite this x coordinate? Gabe?
Alright.
There'll be a negative sine theta. Why is it negative?
Because it's in the second.
Because it's in the second quadrant. Okay? So this reads as negative now, like a negative x value. Okay? This one here, our cosine, our y coordinate is going to be, Terry? Positive what? Good. Positive cosine theta. Okay. You good, Zach?
But isn't, if it's past, right, isn't sine positive in second?
Yeah. Let's not, actually not related to that. So good question.
It's just the same length.
It's just the length. We're just looking at the length. Yeah. Okay. We're good? Okay. So it's, I know some people mentioned it's CAST. However, we're only looking at the value of the x and the y. Just stay in this mode for now, if that helps. But I can rewrite this now. Okay. I can rewrite this as in all coordinates, we always do cosine sine. But if I want to use cosine and sine, what's my new angle that I write in there? And it's staring at you.
Pi over 2.
Pi onto what? Plus or minus.
Yeah.
And we do the same over here. And you can see how these two are now equal, which gives us this equation here. And these two are now equal, which gives that equation here. So we don't just randomly say use that. It's coming from somewhere with this symmetrical rotation on the 90. And if you didn't get that, that's okay. As long as you have this on your summary sheets when you need to use it. So
do we get a theory for both parts?
So the first part, pen. Part 2, Kaz and open book.
For the first part, we don't get a book.
You get a pen, your pen that you bring.
Alright, and then the next part we get both.
Yeah. Okay. All right. Let's do some questions.
So are we doing it in class or like after school?
In class? Okay. Okay, so those two questions are up there. They give you information, they give you the question. But in the question shows you that we can see we kind of really need to use our equations that we know. We can see that this is a pi on 2 takeaway. Okay? So what am I going to do? What is this? What is this also equal to? Depending on, do I use equations 1, 2, 3, or 4?
1.
1. So now I just punch that out. Okay. Oops. Punch that out. Can we see that I can simplify that using the equation? And then, where is this also? It's up the top. So you just censor that. Nice and simple. Cosine pi 2 plus theta. 1, 2, 3, or 4. Where do you see it?
4.
4. So we write it's equivalent. Okay. Final answer.
Maybe 0.4.
Maybe 0.4. These look hard, but got these done. Any questions? Let's do one more. Okay. Gonna wipe this off, create some space. There's two ways to do this. You might find another way. When you have given it a ratio, what's this? What should we do with this? It's telling us something.
Which quadrant?
Exactly, Tim. Which quadrant? And which quadrant? The second quadrant up here. So we know we're in here between pi on 2 and pi. I'm going to get some textures next class. Okay. This is one way you can do it. I've got an angle over here. Okay. Sine it. I think I made a mistake on my notes. We'll just keep going. We'll keep going. I might have to fix the question. Now, cosine theta is 4 and 5. Where am I going to put my 4 and where am I going to put my 5? 5 on the hypotenuse and 4 in the adjacent. Okay. Now, how do I find this?
Three.
It's 3. Why is it 3? It's the triangle, okay? What type of triangle are we talking about, Zach?
You know what it's called? We learned about it in physics.
Oh, okay.
So you can scale it up as much as you want, and it will always be the same side.
Okay. Yes. It starts with T. I think triads. Is that with triples?
No.
Oh, something else. Okay. Okay.
Yeah.
But remember, let's say if you didn't know it, use a Pythagoras. Okay. Okay. 3. Whoops. 25 minus 16. 9 x squared. X equals 9. We're good with that? X equals 3. We're good with that? Okay. So that's that. Have I answered the question though?
No.
No. So if I want to find sine, what's my answer, Maya? 3 and 5. You just grab the opposite and your hypotenuse. Okay? That's how we do that one. Any questions? Okay. Yeah, if I want to find the tan, this is where we're going to be a bit careful though.
-3.
It is a negative 3 on 4. Okay, we'll get there. We'll do it from the start. What's my opposite? Zaid? Sorry? Tan. If I want to do tan, opposite of adjacent from this angle here, what two numbers are involved?
3 and 4.
3 and 4, which we found out from before. Remember, it's just an O and M. Yeah, it'd be a good idea to get into the practice of doing things like this. That dash means we've got an answer, but we're not sure if that's the exact answer based on the domain. Now, Tim has said it's a negative because we know that anything in here is a negative or a 10. So we need to, the real answer is a negative 3 on 4. Okay? It's the domain. Any questions? There's another way to do this. All right. Now, can anyone tell me if this is the unit circle? How long is this line?
1.
It is 1. What's an equation that you can generate from the information given here? The hint is, well, if I give it away, you already know. You got 3 sides here. Finish that equation. What's it going to equal to? 1. Good. It's Pythagoras. But they write it weird. They don't write it like that. They write it like this. That's another useful tool that you can use. If I want to find sine, what can I change this to? Emily, this, what can I change that to based on information that I already have in this question? Remember, this question is over here, starts over here. 4 and 5. Okay. So we can do that. And if I want to find sine theta, what's the first thing that I need to backtrack, Nathan? To get to this? Not quite. That's okay. It's Friday. Manny,
Triangle?
not so much, no.
No, it's not a triangle. Oh.
Okay, I'm just going to clean this up for people. Who you got an idea? Thank you. We're backtracking. Okay. 1 take away 16 on 25 is the same as 25 on 25. Take away 16 on 25. Okay.
9 on 25.
9 on 25.
And square root.
And a square root. It's all. Because of 3 on the 5. Okay. Now, whenever we do a square root, what must we always do?
Plus and minus.
A plus and minus. But why am I going to choose the plus one? Anyone? Why do I choose the plus and negate the negative? Because Zach is pointing at this, which is a puzzle. Okay. Lastly, to get our 10, remember for 10, it's a good idea to put a dash as our preliminary answer. What is tan really? Something over something. It's a sign on cos. Thank you, Manny. And we've already got this information here. With a 3 on 5 divided by a 4 on 5. Flip them over. You can sort of see that you're going to cancel 3 on 4. Okay. And once again, we need to reach the conclusion that this is the preliminary answer, but the real answer is a negative 3 on 4. Once again, because of the quadrant. Okay. If you did them differently, there's no more, you don't get more marks for doing the harder version. Okay. Working out answer. Any questions?